I'm very clear that I'm the one who stands between having fun in San Francisco and in my presentation. So I'm going to try to be very quick and hopefully you know and heard enough about Qualcomm Life over the last few years. So you know what business we're in, and I'm going to skip a number of slides. So let's go to the first chart, or I guess I'm the one controlling the charts. So Qualcomm Life has been in the business for about four and a half years. We are a fully owned subsidiary of Qualcomm. Our focus is really on enabling Internet of Medical Things. And with that, we have integrated over 150 both consumer and medical grade devices. We take a very special care in terms of the way we do the integration. We actually write device agents for every single device that we integrate so that we can capture all of the types of information that devices can put out. And the system is fully compliant. It's MDDS Class 1 FDA platform. We are CE marked in Europe, and the platform has been now launched in 34 countries, and we're adding more and more countries. Qualcomm is not involved only in one vertical. We work in many different verticals, but by far, healthcare is one of the most dominant verticals where we're investing a lot of money as well as buying a lot of companies. So it's been an investment. So we're not just growing organically, but also inorganically. Okay, so over the last 18 months, we started to develop new business within Qualcomm Life, and it's called TuneNet Design. And the focus of this business is to enable drug delivery devices as well as patient monitoring devices with a variety of connectivity and sensor options to capture all kinds of information. And really, we work a little bit differently from the way that some of the other companies that have worked in this space. We develop custom reference designs for pharmaceutical industry where we capture the requirements. We try to understand what kind of data is required, what the pharmaceutical company needs to capture through the device, what are some of the issues that they're trying to solve, whether it's adherence, compliance, persistence, and as a result, we work on the type of sensors and the type of connectivity that matches the drug delivery options that are currently available on the device. And we've done a number of them already. The one that I'm going to spend the next few minutes describing is going to be the inhaler. The one that I will show you is more or less a generic inhaler. It's not the one that will be launched by Novartis in 2017, but I think it will convey the message in terms of what we're trying to solve. As James from Ethereum has spoken about the importance of capturing this type of information, we have done this work now not only on the inhalers, but also on smart injectors, smart blister packs, and so on. And depending on what is needed in terms of the information, that's what we try to ensure the device is capable of transferring. The system is the same. It's a TuneNet platform, which is, can capture data both using the phone as well as the TuneNet Hub. TuneNet Hub is really, and let's switch to the video now so that you can see. So this is the hub, which it has exactly 0 buttons on it. It comes only with 3 different plugs, US, UK, and Europe. And inside the hub, you will find it's actually an Android phone that sits within the hub. And the same capabilities are available through the phone. So what we can do is, and this is the inhaler. It's a generic inhaler. Hopefully you could see the connectivity module that sits inside this inhaler. We specifically made it transparent so that you could see how the connectivity module was embedded inside the inhaler. We have a number of different things that were requested by the company. In this case, Novartis wanted to capture both the duration of the inhalation as well as whether the inhalation was done properly or not. So in this case, what you have is you have a microphone inside the inhaler as well as accelerometer. So depending on how the inhalation was made, what was the position of the inhaler, we would capture this information. Obviously, we capture date and time stamp of when the inhalation was made. And then the microphone, depending on how the inhaler was placed in the mouth, we can tell whether the inhalation was done and what was the duration of the inhalation. So if it was only inhaled for, let's say, for 5 seconds, and whether it was actually fully placed inside the orifice of the mouth, that can tell you they can explain on whether you're actually getting the full amount that is needed from the dose. Now, in terms of the accelerometer, again, if the inhaler was used incorrectly, you can push the information to the patient. It could be educational, it could be motivational information to ensure that in subsequent inhalations, the patient is doing this correctly, and you can actually provide some level of intervention into the therapy to ensure that you could drive adherence, compliance, and obviously persistence. One of the other things that is interesting is you could see we did not modify the inhaler. So you've seen some examples which are very clever where you can place kind of like an add-on, clip-on top of the inhaler. What we try to do is something different here, is we want to make sure that we do not change the packaging, primary or secondary packaging, visibly or physically, that the inhaler, the footprint stays exactly the same. When we receive the inhalers or other drug delivery devices from the manufacturer, we do an X-ray, we take it apart, and then we look at the real estate availability within the drug delivery device to ensure that we can place the connectivity module and the sensors inside the device. And that gives us an option of making sure that it's easier to introduce this into the market. And also what we want to do is to emulate exactly the shelf life of the original device. So let's say if the shelf life of the inhaler is 2 years, we want to make sure that the battery capabilities and the inhaler itself and the connectivity module are completely aligned, so that if it's a disposable device, you will dispose it exactly like you do the regular inhaler, throw it out along with the connectivity module. That brings another point. You have to make it very inexpensive in single dollars. You have to ensure that the disposability of the device is clean and can be done correctly, with the regulations and of the specific geography where this inhaler is going to be used, whether it's Europe, US, Southeast Asia, or whatever. And that's also in terms of the battery, once the device is actually, not only the shelf life, but also once the device is activated, let's say it's a 30-day supply within the canister, you have to make sure that the battery, once it's activated, can last for 30 days. So that's a level of testing that we do internally to make sure that these devices actually match what is required by the manufacturer or the sponsor of the device. And like I said, this is an example reference design of the inhaler. We specifically made it for the conference so that you could see the connectivity module. But it's very similar to what we do with other devices, such as smart injectors, as well as patches. We are also working on the oncology patch, which will provide clinical thermometry as well as ability to measure fatigue. There would be an indirect clinical endpoint, again, associated with activity monitoring. But those are some of the examples, and hopefully that gives you a sense of how this device actually works and how we integrated the sensors and connectivity inside the inhaler. And I'll stop now, and thank you very much.